All right, here's the video for mole conversions. Um, if you missed it, you can use this to help you out. Excuse me. Um, so what you need to do mole conversion is a periodic table and a calculator. Okay, so always have that with you, and the chart that I gave, or the diagram that I gave you in class. Okay, so what is the mole? A counting number, like a dozen. Okay, so Avogadro's number is what we use as our counting unit for 1 mole is equal to 6.02 times 10 to the 23rd particles, atoms, molecules, formula units, ions, etc. And that's where we're getting that number from. So for every mole of any substance, if I have a mole of pencils, I have 6.02 times 10 to the 23rd. We're going to cut, this one has one extra 2 in it. Don't worry about that. If I had a dozen eggs, I'd have 12. If I had a dozen pencils, I'd have 12. But if I have a mole of eggs, I have 6.02 times 10 to the 23rd. Okay, so molar mass of 1 mole of an atom, of an element or compound, is the atomic mass on the periodic table. Okay, so the mass of each element tells us how much we have. So Avogadro's just discovered that the relationship between the number of particles and volume of a gas was the same in every one of them. So that's why he did that. This was used to find the relationship between the moles. Okay, so how is molar mass expressed? Well, if carbon, you go to the periodic table, it's 12.01 grams per mole. Aluminum, 26.98 grams per mole. Zinc, 65.37 grams per mole. We're going to round to 2 decimal places just like we did with everything else. Okay, so water, got molar mass, you break everything down. H, let me do it the way we did it in class. So you have H equals O equals, you put a 2 and a 1 times 1.01 times 16. We're going to round, which when you multiply across and add down, you get 18.02 grams per mole. Sodium chloride, NaCl, 1 times 22.99, and then this one is 35.45. You multiply across and add down. This is 4, 8, 58.44 grams per mole. What does that mean to us? It means that for every mole that we have to have 58.44 grams. Okay, we're going to get through that. I'm going to skip these. You can copy them down if you want to. This did it in a line. I do mine in a column. Okay, so mole conversions. It says how many moles of carbon atoms are in 26 grams of carbon. So here's what you do. You circle what's given all the way to the unit. This number goes here, 26 grams of carbon. You underline what you're looking for. Okay, what's on the top, bottom, grams of carbon. And then what you underline goes on top, moles of carbon. Okay, now because it says grams, we go to the periodic table and we look for carbon. If you look at carbon, carbon has a molar mass, we'll put it over here, of 12.01. All I have is carbon, so that number goes right here, 12.01 grams of carbon. You look on your chart and this is a 1. Okay, so that diagram that has the circles and the oval, you follow the arrow and you'll see that moles are over molar mass. Okay, a 1 goes here. Cross out your 1s. Play Harry Potter. Get rid of your things diagonally. If something's on top and something's on the bottom, then you would divide. If they're side by side, you multiply. So the answer would be 2.2 moles of carbon. Okay, so we can go back and forth between moles and particles also. So we just did moles and grams. We can go back and forth. That's why there's 2 arrows. We can do anything through the mole. I'm going to go ahead and get rid of this. So again, if you want this down, copy it down. Okay, so same before, how many moles are in 2.50 moles of C12H22O11? You circle what's given. Okay, you underline what you're looking for. Sorry about the circles. My pen is really hard to use sometimes. Write down what you're given. 2.50 moles C12H22O11. Okay. Then what you have on the top, you put on the bottom. And I'm gonna H22O11. Okay. When you look on your diagram, we're going to molecules, so you go molecules. Okay. See, Okay, so then you look on your diagram with the circle and the oval, and you'll see that there's a 1 here, and then there's a 6.02 times 10 to the 23rd. Okay, to put that in your calculator, you would do 2.50 times 6.02, second button, x minus 1 button, which has an EE on the top of it, and then you put your exponent 23 and hit equals. When you do that, you should get a very large number. So we're going to go ahead and get the answer, which would be 1.51 times 10 to the 24th molecules of C12H22O11. Okay? So again, if you have 2.23 atoms of sodium, okay, so here's what you're doing. Atoms of sodium, how many moles? Okay, so you put everything here. You put 2.23 atoms, because this is what you have, of sodium. Okay, what you have on the top, you put on the bottom. And then you put your you put what you're looking for here, which would be moles. Go to your little diagram, and you'll see that there's 1 mole over 6.02 times 10 to the 23rd. Put a 1 here. Get rid of your 1s. Play Harry Potter. Okay? When there's a number on top, a number on the bottom, you again put this in your calculator. And I forgot to put this down. Times 10 to the 18. Okay, so in your calculator, you put 2.23. You hit your second button. That's a second button. Your x minus 1 button. You put 18 divided by, because one's on top, one's on bottom, 6.02. Second button, x minus 1 button, 23 equals. And when you do that, you will get 3.70 times 10 to the negative 6 moles of sodium. It's a very small number. Okay? All right. I'm gonna go ahead and just put this out here. You play Harry Potter. Okay. And then you divide. Nope, I'm sorry, you multiply and you get that answer. So we can also do mole conversions from mass to moles, and then from moles to particles. Okay, so keep that in. We're going to do that in class also. Excuse me. Sorry. So if you have any questions, come to class and ask me. All right, have a good day.